Alright, in this video we're going to look at how to solve more complex type of shapes. There are several strategies, and we're going to kind of explore them as we go through here. So in this particular position here, I'm trying to find out all these other angles. I know these lines are parallel as indicated by these markings right here. That means these lines are parallel. So if you have parallel lines, you can often find some angles from that. So like we know this is 45 degrees. Well, this angle right here then is also 45 degrees because of their alternate interior angles. So whenever possible, make use of parallel line theorems that we know. That's something you're going to want to consider. All right, so we know that. The next thing we do is, again, the triangle angle theorems. So like the interior angles, the fact that they add up to 180, the one we learned about the exterior angles. So if this is 50 and this is 45, then what does this have to be? They have to add up to 180. So 50 and 45 is 95. So 95 plus y is 180. Just going to solve for y. In this case, it ends up being 85 degrees. So that's how we can find y equals 85. Okay. Now we move on from there. We can write an equation because we know this, we know all these angles. We may not know their exact value, but we have enough to write a relationship that 45 plus x minus 15 plus 2x equals 180. So that becomes 30 plus 3x equals 180, which becomes 3x equals 150, which becomes x equals 50. And then if you plug in, 2x becomes 100, and then this becomes 35, and this all checks out. 135 and 45 add up to 180. So x equals 50, y equals 85. But those are the theorems that we use to get us through. So parallel line theorems and the triangle angle theorems are a good start. Next, we also learned some theorems involving isosceles triangles, the base angle theorems. So remember, what that says is that if an isosceles triangle, if two sides are equal, then you know whatever angle across from them, this is 70, then this angle is also across, this angle has to also be 70 degrees. So we've got some base angle theorems, or some other methods we can use. And so what else do we know here? Well, same deal. This angle is congruent to this angle, so that means that this side is congruent to this side because of the base angles theorem here, or maybe that's the converse. But these are all now congruent, so that means you can say that this side is equal to this side. So because if this side is congruent to this side and this side is congruent to this side, then they're equal. So we can write 50 equals 2x plus 6, so that means 44 equals 2x. So 22 equals x. So the value of x is 22. And now I'm trying to find this angle, so I say, what do I know? Well, this angle is 40, and these two angles have to be the same. So essentially that means 40 plus y equals 180. Because if this one's y, this also is y. And then we can solve that. We'll end up getting 2y equals 140, so y equals 70 degrees. And so we get that. So that's another method to solve these. Let's do one more. All right, so in this situation we have a lot going on, a lot of different isosceles triangles. We're just going to follow the lines, figure out what we know. So these sides are all congruent, which makes that a special type of triangle called an equilateral triangle, which means all these angles are equal. So if they're all equal, and they all have to add up to 180, that means they all must be 60 degrees. And we could do that mathematically with an equation, but it's just something you'll start to know for an equilateral triangle. Okay, what else do we know? We know that this side is congruent to this side. And this side, the angle across from it's 50 degrees, so that means this one must be 50 degrees. And if that's 50 and that's 50, then that has to be 80. You can just fill that in. And then say, well, what do we know about this angle? So another theorem or thing you can use is linear pairs. This isn't quite a linear pair because there's actually three angles. But the same concept of if you have a line, you know it has 180 degrees in it. So we have 50 and 60, that means this must be 70 to make it 180. And if this is 70 and this is across from here, and this is congruent to this must also be 70. And therefore this angle here, 70 plus 70 is 140, this angle must be 40. So a lot of making use of this base angles theorem to figure this out. So that's going to get us to x equals 40. All right, now we're still trying to figure out what y is. So we know that this part of the triangle is 30. So that means that this part of the triangle is also 30. And if this whole length is 80, then it means this length right here is 50 from here to here. And we know that this side is congruent to this side, so we could say 50 equals 2y plus 10, 40 equals 2y, and so 20 equals y. And that's kind of a method. I know I did that quickly for solving a situation like this. Really, the best way is just to practice, do problems with this, try out all these methods, but that's really the best way to make sure you understand this. Don't just follow along with what I'm saying, because it'll make sense when I'm saying it, but it's another thing to actually do it. So until next time, I am Derek Genova. Have a delightful day.